their specifications are platform independent. The architectural framework can be implemented on heterogeneous software and hardware platforms. And the very important point is that all APC global standards they are they are providing it open for extension. So here are two graphs that shows the architecture of the APC global framework. The important thing here to mention is that the framework we can divide in three parts to identify, capture, and exchange. My thesis most probably works with the capturing and filtering layer, which contains application layer event, reader management, and also low-level reader protocol, which is, we can say, it's as I mentioned before, where the base context filtering is done. So, as you can see, there is a problem in this network, and from this problem, a lot of things depends. It depends how good you are implementing the anti-collision algorithm in order, and this tells how good is your system is. If you can manage a good anti-collision algorithms to implement, your system can be very valuable. And as we can see, it can be two types of the reader collisions. One is tag interference and another called frequency interference. Frequency interference occurs when two or more neighboring readers work at the same time using the same frequency, and tag interference occurs when two or more readers collide with each other at the tag if they send the data packages at the same tag simultaneously. So, as we have seen, the problem is coming from because in a network we can have multiple readers, multiple tags, and also limited channels. So, Professor Soldatos provide very nice topic for me for my thesis, and I decided to work on it, which is about the anti-collision algorithms in the RFID heterogeneous networks. And my solution was implemented in Aspire RFID project, and IETIS has a major role in this project, and is sorry, and he has a leading role in this project, and I contribute my work on it. I decided to mostly to implement two things: the simulator for the RFID reader and function and implementation of functions for managing heterogeneous readers in RFID networks. Sorry, just take. So let's start speaking about my solution. My solution includes to extend functionality of application layer events to support event cycle division between neighboring readers. Also create neighbor reader manager for each group and divide reading cycles between neighboring groups. Extend the functionality of the logical reader specification, and also, because we have only one reader in the AIT lab, to create a low-level reader simulator in order to be able to check my work and to see the results. So, as I mentioned before, I have mostly worked with application layer events, reader management, and low-level reader protocol. So, what is the goal of the application layer event? It's to reduce volume of data for readers to application, elevates level of abstraction for application writers, share data among multiple applications, also integrates easily using standards like XML and web services, and also extensible to vendor changes. So it's the, if we'll say roughly about the application layer event, it is enabling clients to say what kind of data they want, and the application layer event is providing interfaces to be able to capture this data and to provide to the client. It has 5 interfaces: reading API, writing API, tag memory API, logical reader API, and access control API. Both reading and writing APIs are most for the application control, and the other remaining 3 are for the setup and administrative controls of the tags. ILA has the application layer event has 3 operational modes: subscribe, pull, and immediate. The fundamental concept of application layer event are following. It has reader cycles, which is the smallest unit of interaction with the reader. It has event cycle, during which interval of time ILA implementation carries out interaction with one or more readers on behalf of application layer client, and also after finishing the event cycle, ILA replies to the client with the report. Report is responsible to send to the client a conclusion of an event cycle or a command cycle. Event cycle, if we'll speak a little bit more details about the event cycles, we can say that it's the smallest unit